In this module, we are going to actually understand the details of a very cool convolutional neural network application called neural style transfer. So the problem setup is the following. Let's say this particular image on the left is, let me call that image as a content. And this image on the right, let me call that image as style. So that's a style image. So the idea is to mix the content and style in such a way and generate a new image that actually reflect the content as well as the style. So portray, for example, this content, portray the style or embed the style on this content so that the content is also visible, but it looks like the whole style is I mean, just map different style on the content. So this kind of problem is known as neural style transfer, and it turns out that convolutional neural networks are really handy in achieving the solution of this particular problem. In a nutshell, let me define certain things how this problem basically is solved. So if I call this image as C, and if I call this image as S, I should use a different color here. It's a multicolor thing. If this image is S, it's still there, S. If this image is S, this image is C, and let me call this image as generated image as result or R. The idea is that R, the resultant image, should be closer to C, as well as the resultant image R should be closer to S. So the cost function really is to build to come up with this resultant image that has similarity with the content image as well, or the content, and it has similarity with the style. So if I write the cost function in terms of, if I write the cost function for this particular problem, it should be the following. So the deviation or the distance of resultant with the content, that is, so we can define this. We will later see how to design basically this deviation function or this distance function. So this should be minimum, and that is sometimes called the content cost. Similarly, the deviation of this resultant image from the style image, that should also be minimum, and sometimes this is called the style cost. And these two costs can be merged using hyperparameters alpha and beta, and that's the total cost function or loss function, which basically is parameterized by R, because this is the R that we really need to adjust. So what happens is we want to minimize this loss function, and we want to generate this R. So when the algorithm basically begins, it randomly initializes this R, because R is the parameter. It uses a pre-trained network and some of the middle layer as the activations of some middle layers as to define this content cost and style cost. We will see some of the details shortly. But given a pre-trained model and this content image and style image, you randomly initialize this R, which is the resultant image, and apply gradient descent to minimize this loss function over time. And that's how you generate this resultant image. About some of the details of how the pre-trained models are basically used. It is important to note, and we also have basically described that earlier as well in the visualization section. Earlier layers of any convolutional neural network, they actually so the early layers, they exhibit the low-level features, low-level details, and the deeper layers, more deeper layers, they actually capture more high-level patterns or complex patterns. So the idea to define these content costs and the style cost is to pick a middle layer or a layer that is not too early and not too deep. So pick, for example, let me focus on the content cost. So for example, pick the pick some layer L as a layer, content layer, and choose its activations. Let me call the activations of that layer as AL. And these, let me call these activations as CL, so activations on C. So let me use that. So let's say we have decided layer L for content. So we use the activations of that layer for C, which is the content image. We pass this image C through the convolutional neural network up till this layer L. And the activations of layer L, they are basically our feature map for content image. And again, this layer L, choosing this layer L is again a hyperparameter, but the heuristics are to not go too deep and not stay too early. It is somewhere in between the network. And then you actually, for the same layer, you compute the activations for resultant image that you have described as randomly. And you can actually just compute the Frobenius norm of these two tensors or matrices, or just flatten them out and compute L2 norm. And that is the content cost function for the content. So that's the content cost. The style cost is a bit different. So let me focus now on the style cost. So the style cost, however, involves again selection of a layer and sometimes multiple layer. So let me focus on just one layer. Let's say we choose layer K for content cost. Let's say we pick layer J for style cost. And normally multiple consecutive layers are picked for style. But what happens is, let's say these are the activations for C. And let me write these activations in terms of volumes. So these are, let's say, the activations for C. And let's say we again have activations for S as well for this particular layer. Let's say these are the activations for S, R, our resultant image that we have randomly initialized. Let's say this particular image has N channels, and let's say this also has N channels. So the style is computed by taking cross correlations over channels. So for example, what you do is you pick the very first channel. So let's say you pick the channel I. Let's say first channel, which is the first band or first matrix in this volume. And that is 1. And then you pick the second, that's another matrix, and compute their cross correlation. And that will bring you one number at the end of the day. And place that number, for example, at location 1, 2. Similarly, take the cross correlation of the first matrix with the third one and compute a number and place there, and so on. This way you will compute actually pairwise cross correlations in the dimension of the number of channels, and the resultant matrix will be number of channels by number of channels. So that's the cross correlation over channels. And similarly, you compute cross correlations over this R image, and that is also again an n by n image. Let me call this as C L J. Let me call this matrix has C cross correlation for CC, and that matrix has R C and LJ. And then this content cost basically is simply the two matrices, the cross correlation matrix for layer LJ and the cross correlation for layer LJ for both content and resultant images, and take their Frobenius norm or L2 norm after the flattening out the two matrices together. And sometimes this actually happens for multiple. So for example, this J varies from maybe 3 to 7. So you may have picked multiple layers to actually perform this kind of, and this actually brings the content cost, and then you mix the two costs using these hyperparameters alpha and beta. And you can use any pre-trained model, as we saw that the middle way layers, preferably on ImageNet data and stuff like so. If a convolutional neural network is trained on large data set, then you can pick any pre-trained data set pre-trained model and pick its middleware layers. You have your content image, you have your style image, just randomly initialize your resultant image and apply gradient descent to actually reduce this cost. So that's the problem setup. In the next video, I'm actually going to implement that very quickly in very few lines of codes using TensorFlow Hub that we also saw in transfer learning module as well. So let's see how can we quickly apply neural style transfer using TensorFlow Hub in just a few lines of codes. Okay, in this video, we are going to actually use TensorFlow and TensorFlow Hub, TensorFlow and TensorFlow Hub to actually use a pre-trained model and quickly use that model to actually transfer the style transfer the style on the content. So I already have shown you how to work with TensorFlow Hub in transfer learning. In this particular module, we are again using that, and I'll not be going into the details of training the network. Rather, I'll be using a pre-trained network to do that. So let's go to Jupyter and let's import certain packages that we really need. Import NumPy as NP, import matplotlib dot pyplot as plt for images. We can use pillow, but that's also fine. Import TensorFlow as tf, import TensorFlow Hub as hub. So these are the packages we need. They're already installed on my machine. You can install them on your machine, or you can use Google Colab for TensorFlow and TensorFlow Hub, no problem. And next we basically load the images. Let's load the content image. Let me actually go to this content image. That is content. So let me load that image. So C, let the content image be C. So plt.imread r content image. That's the content image. plt.show C imshow. plt.imshow C. That's the content image. If you see, we actually load the style image. So S is again plt.imread r. So the style image has name style here, style, and that's the style image. We can also see the style image, plt.imshow s, and that's our style image. Now we load a pre-trained model from TensorFlow Hub, and let's see. So the model, pre-trained model, is basically hub.load, and the path is https:// TensorFlow Hub.dev Google Magenta arbitrary image stylization, arbitrary image stylization variant 1, and then we basically use 256, and we use /1. So that's our model. We load that model. If the path is correct, the model will be loaded. And that's the model that is actually for style transfer available. There are several other models, but this model is available at TensorFlow Hub. By the way, if you go to the official page at tensorflow.org, they have another full-fledged notebook for actually going through the cost functions that we saw in the last video and actually implementing from very scratch the full cost functions as well. But in this particular video, I'm going to actually give you a very quick start. How can you do that? Okay, the R image or the final R image is basically a model dot model, and then we have basically tf dot constant, and here we have our content image. But what we do is we actually add another axis, new axis in that as a requirement of the model, and then we have the style image, which is this, and we add np.new axis into this style, and we actually do that, and we basically build build that as so this tf dot constant that ends here, and then we have tf dot constant that actually ends here, and then we actually pick this. So it may take a while to actually, oh, what's the error? Oh, we have to convert these images to float first. So yeah, we need to convert these images to float. So why not convert here? np.asArray this and float 32, and similarly np.asArray as float 32. So this is the array and float 32. It requires float 32. The I guess I mixed up these parentheses and stuff, I guess. So np.asArray this, where is tf.constant? That is tf.constant, and then we have this tf.constant. This is and this is for tf.constant, and that is for the function, I guess. So that works. So it may take a while to actually generate that result. So it will actually generate the result in the form of tensor. If you see the type of this R, that will be a tensor. We can convert that to a NumPy array, no problem. So R is basically R static 255, and then np.array this thing, and we can set the D type as np.uint8, and it will then be available as np array. And now if you see the shape, r.shape, the shape of that will be 4-dimensional, 1 by this result. And now we can just visualize this by using plt.imshow r, and we want to skip the first dimension. And here you can see the result that actually has a style as well as that. You can have better visualizations, or you can actually use a different model and stuff like so, but that's the overall model of the story. So that's about neural style transfer. I recommend the reader or the viewer here to go to www.tensorflow.org, tutorials, generative style transfer. And there they also have coded a long notebook for actually building your own model from scratch if you're not going to use, for example, TensorFlow Hub or some pre-trained model completely for neural style transfer. What if you want to, for example, use VGG16 or VGG19 or maybe ResNet or MobileNet or something like that, and using some of its layer, and you are actually going to optimize your cost function. So that is also possible for those who really want to do that. I recommend them to go to the official page at tensorflow.org. So yeah, that's about it. Hope to see you next time.